In this next part here, we're going to look at some word problems that use right triangle trig. First one here, we're told that we have a quadcopter flying over Byron High School. You want to estimate how high above the ground the copter is flying. Now, a quadcopter, if you're curious, is a helicopter with 4 propellers. They're kind of neat. They're a little bit easier to steer around. Although if they spin too fast, they can be a little bit deadly. So if you can get yourself a quadcopter, then you're pretty cool. You're standing 100 yards away from the spot that it's flying over. So if we're drawing ourselves a little diagram, this is the spot on the ground where the copter is flying above. The copter is up here in the air, and you are standing right over here. And that distance from you to the spot on the ground where the copter is above is 100 yards. And it says you measure an angle of elevation of 30 degrees. Now when we're talking about angle of elevation, it is how much of an angle you go from the ground to the object. So you measure starting at the ground, you measure upwards, and that measures up to 30 degrees. So the angle of elevation of 30 degrees means you go up from the ground 30 degrees. It says how high is the quadcopter from the ground to the nearest foot? Now one thing I notice is you do need to be careful with your units. We want to know to the nearest foot here, so I'm going to erase this 100 yards and change it to 300 feet right away, because we know that there's 3 feet in a yard, so I'm going to just change it to feet just so we don't get goofed up later. So now when you measure straight up from the ground, that's going to form a right angle. So we know we have a right triangle. We know our angle of elevation is 30 degrees, so we know that 30 degrees right there. We know the side length on the bottom is 300. We want to know this side length right here, the side length that goes straight up in the air, that tells us how high above the ground the quadcopter is. If we can find a trig ratio that uses the side that is adjacent, right here, this side is the adjacent one, and the opposite side, we don't need the hypotenuse, there's no need to know that here. So if we can find a trig ratio with adjacent and opposite, we can solve this. Write out our SOHCAHTOA. And we see that tangent is going to be the one that has opposite and adjacent in it. So tan of our angle, which is 30 degrees, is going to be equal to our opposite over adjacent. Opposite is our unknown. Adjacent is our 300 feet. Now, since we want to get our unknown alone, that's our whole point here, is to solve for that, we need to get rid of that 300. So we're going to multiply both sides by 300 on top. Those are going to cancel each other out because we multiply top and bottom by the same number. So we can divide those away from each other, leaving us with just the unknown side length on the right. On the left, we have this to type into our calculator. 300 times the tangent of 30 degrees, which comes out to 173.2, or if we round that to the nearest foot, about 173 feet. So the answer to the question, how high the quadcopter from the ground to the nearest foot, 173 feet above the ground. Let's do one more example here. We have a ladder propped up against a barn. It says the foot of the ladder is 6 feet from the barn. The ladder reaches 14 up the barn wall. If we were to draw this as a picture, we've got our ground, we've got our barn here, and we have this ladder leaning up against it. So there's our ladder. and it says the foot of the ladder is 6 feet from the barn. So if we go to the bottom here, we have 6 feet between the bottom of the ladder and the base of the barn. We also, it says it reaches 14 feet up. So we'll mark that as 14 feet. Asks us two questions. How long is the ladder, which is going to be that length right there, and what is the angle of elevation between the ground and the ladder? So the angle of elevation we're going to need to solve right here. Now the question that asks us the side length here, the length of the ladder, is probably going to be the easier one to solve because we have a right triangle. We have a short leg, and then our hypotenuse. So we can just do Pythagorean theorem to solve that. So Pythagorean theorem says that we have a squared plus b squared is c squared, or short leg plus short leg equals hypotenuse, and we square each of those terms along the way. So if we do that, we can type in our calculator in one straight shot here, 6 squared plus 14 squared, and that's going to come out to 232. So that'll be 232 equals our unknown side squared. So we need to square root both sides. So square root of our answer. Again, if you're wondering why no plus and minus, it's because we're finding the length of a ladder, and the ladder is probably not going to be negative so many feet long. So our unknown side, the length of our ladder, is going to be 15.2, and we'll round it to the 0.2. So 15.2 feet. And that's for the ladder. Now we also need to solve the other part of this question, which was that angle of elevation. The angle of elevation is going to require a trig ratio. So we're going to want to find something that uses the angle, or the side that is opposite and the side that is adjacent, because we have the opposite side 14 and the adjacent side of 6. So if we think of our SOHCAHTOA, we have opposite and adjacent in the tangent function. It's going to be opposite over adjacent. So we write tangent of our angle, which is unknown, so let's call it theta this time. So tangent of our angle theta is equal to opposite, which is 14, over adjacent, which is 6. We need to get theta alone, so we take the inverse tangent of both sides. And when we do that, the inverse tangent and tangent over on the left cancel each other out, leaving us just our angle theta. And the inverse tangent, second tangent of 14 divided by 6, is going to be 66.8 degrees. And since it doesn't say anything, we'll round it to the 10th. So 66.8 degrees is our angle of elevation. Quick common sense check to make sure that seems reasonable. We look at the picture, and it looks like this is definitely more than 45 degrees, but less than 90. So saying this angle down here is 66.8 seems totally reasonable.